All right, the last week of Math Activate questions. Hopefully you've been getting better at them all along. I love this problem. It just makes my geometry mind go crazy. I love it. So if you look at this cake, he baked a cake for his math club groupies, just like everybody would. So it shows you the dimensions they mentioned up here in this top area. It's 3 inches high, 16 long, 12 wide. It also mentions down here that they leave 2 inches width all the way around for the aluminum foil thing that it's sitting on. So it says, what is the area in square inches of the aluminum foil that is exposed on the top surface of the cardboard? Okay, so basically they're wanting the area of this all the way around. So we got to think about subtracting off certain things. We really don't need the height of the cake or anything like that. I'm going to draw us a new picture. It looks square, but it's not. There we go. Okay, and I'm going to put the cake in here. Let's go ahead and put the dimensions of the cake. We know that this is 2 inches, right? And it's 2 inches all the way around, everywhere. And the dimensions of the cake are 12 by 16. We don't really need that 3 right now because we're not dealing with 3D. We're just doing area. So we want the area... okay, that didn't work. It was a good try, though. We want the area all the way around right here, just on the aluminum foil. So what we're going to have to do is find the area of the big rectangle, subtract the area of the little triangle. Or you could break it up into a bunch of little rectangles and find the area of each one, but that's just not as much fun. So the little rectangle, we know the area is length times width, which is 12 times 16. Okay, so that's going to give us 192 for the area of the little one. And then for the area of the big one, we got to figure out how long these whole sides are. This is where most of the mistakes happen. Most people want to say this is a 14 by 18, and they only add that 2 on one time. But if you look at the length here, from here to here is 12. See how it's just this part? And this width is 2. This width is 2. You actually have to add it on 2 times because you got to add it on to both sides. Same thing over here. From here to here is 16, but then this width would be 2, and this width would be 2. So that's actually 2 plus 12 plus 2, which is 16. And then 2 plus 16 plus 2, which is 20. And if you multiply that, that's going to give you 320. Okay, so now we have both areas, and that's where most of the mistakes happen, is not adding it on twice. So we're just going to do 320 minus 192. Okay. And that's 128. The coordinates of the excuse me, of the endpoints MN is the standard XY coordinate plane are -13, -4, and 5, 4. So that means this one's M, this one's N. What is the X coordinate of the midpoint of MN? Okay, it only wants the X coordinate, and it wants the midpoint. So remember, midpoint's right in the middle. There's a midpoint formula. It's basically averaging the X's and averaging the Y's. If you can remember that, it's not that difficult. So if we want to find the middle X, we're going to use our X's, -13 and 5. To average something, you add them up, and then you divide by how many you have, and we have 2 X's. And that's going to give you the average X, which is also your midpoint X coordinate, the middle point on the segment. So -13 plus 5 will be -8. Divided by 2 is -4. Okay. On the coordinate plane, we're going to be doing a kind of a transformation. The next part of the assignment is to reflect the trapezoid across the x-axis. Okay, reflect across the x-axis. So even though they put this line right here, it's very deceiving. You're not reflecting across it. You're reflecting across the x-axis. Let's draw that on there. So we're going to reflect across here. And I'm going to go ahead and do that just for fun. Okay, so here's our reflected trapezoid, and if you notice, the way you reflect it is this point is 1, 2 away from our reflection line. So we want to go 1, 2 from our reflection line. That's how you do all 4 points and get your trapezoid. So it's asking you what your new equations would be, and for those equations, notice they're inequalities because they want the shaded part inside. So basically, it's kind of like linear programming, if you remember those terms. So we want to figure out what these equations are first, and then we can narrow it down. This equation was y equals 2, and now instead of being at 2 on the y-axis, we're down here at -2. So this is the line y equals -2. So let's look down there and see if there's any that don't have a y equals negative 2. Okay, we're going to have to wait on that. So the next one was y equals 5, and this is moving down instead of at positive 5. It's now at negative 5, so that's y equals negative 5. So now we can look at that middle equation. These in here, it's not from positive 2 to 5. It has both negatives, so we can actually go ahead and mark out A and D just based on that. So now let's do the other ones. This one is x equals 10, and if you look, they're actually still exactly on the same line. So this one right here is still x equals 10. So we can get rid of anything with a negative 10. That's not correct, so we get rid of E. So now we already have it narrowed down to B and C. So our last equation, this was the line y equals x, and the reason it's called y equals x is, well, first of all, it goes through 0, 0, it's your y-intercepts. That's y equals x plus 0. Remember, y equals mx plus b. And also, your slope is 1, which means rise 1, run 1, rise 1, run 1. I like to think of y equals x being literally your y's are the same as your x's, 0.00, 1, 1, 2, 2, 3, 3. And now it's just going the opposite way. You can see that line is right here, going the opposite direction. It's the same line, but with a negative slope. So this is y equals negative x. So now from the two we have, they both have y equals negative x. So now we're going to have to look a little closer at the inequality symbols. So I'm going to switch colors. Let's look at the, let's see, it starts with a 10. Both of the 10s are the same, so we don't have to worry about that. And then both of the negative 2s and the negative 5s are the same. So it's only the difference in that last line, whether y is greater than or equal to that line, or if it's less than or equal to the line. So if we look at this, I like to think of greater than being above or on top of the roof, if you think about the line being part of a roof on a house, and less than being underneath or in the house, under the roof, below it. So if we wanted to shade in the shape, it would have to be above the line or above the roof, right? So that would be a greater than. So let me find the right one. That would be B. Number 4, in the standard coordinate plane, what is the distance between -3, -2, and 5, 5? Okay, so you have two options here. You could do the distance formula, or you could plot them yourselves and do Pythagorean theorem. I'm going to show you both very quickly. Okay, our distance formula is a square root of x minus x squared plus y minus y squared. It does not matter which order you plug in your x's and y's, because that squared is going to make it positive anyway. So I know most of the time you say little subscripts, but technically they don't matter. It doesn't matter which x you start with. So let's go ahead and plug in. That would be -3 minus 5. That's my x's squared, plus -2 minus 5 squared. Okay, so I'm going to simplify that. A lot of people try to put in their calculator all at once, and you need to be very careful with that. Okay, so -3 minus 5 is a -8, and it still needs to be in parentheses. That is very, very important. -2 minus 5 is a -7 squared. If you forget your parentheses in your calculator, it's going to give you the wrong answer, because when you square a negative, the negative should go away. But if you forget the parentheses, it doesn't get rid of the negative for you. So make sure you do that. Once you get down beyond this step and you square it, there should never be a negative number. So -8 squared is 64. -7 squared is 49. And when you add those together, 113. Okay, so that's a square root of 113. What you see is right here. Okay, you could also plot those points on the coordinate plane. Once you plot them on the coordinate plane, this is -3, -2, and +5, +5. You can do the Pythagorean theorem if you create yourself a triangle. Okay, so on your triangle, that's going to be a right triangle because you have a horizontal and vertical line. You just have to get the length of this one and the length of this one. So from here, that's a distance of 3, and that's a distance of 5. So this will be a total of a distance of 8. This one's 2, and that one's 5, so that's a distance of 7. So to get this length, you would do Pythagorean theorem as a squared plus b squared equals c squared. So you could do 7 squared plus 8 squared is equal to c squared. So 7 squared plus 8 squared is 113. And then to finish solving for c, you have to square root to get rid of a square, and that's going to get rid of that square. So you can see again we got square root of 13. Doesn't matter which way you do it, it's going to give you the same answer. Okay, last one. One side of a triangle is 15 centimeters long, another side's 28 centimeters long. Which of the following is the possible length for the third side? Okay, you got to remember that to make a triangle, this is a long time ago. Some of you may have not even covered it. Think about taking three pieces and trying to make a triangle. These two have to be long enough to be able to meet each other. So think about swinging these back and forth. There's no way to make them touch and make a triangle because these two small ones are too short. And then think of the one where we have two lengths. If we hook them here, go to here, and let me switch colors again. And then you have another one that comes over here, and they barely touch. Once you try to move them up to make a triangle, they're going to come apart. Okay, once you try to move them up to make a triangle, they won't touch anymore. They're not long enough once you start moving them upwards. So you still can't make a triangle if they just barely touch. They have to be overlapping. So just think about what a triangle looks like. If we took these pieces and laid them down here, this one would come down over to about here, this one would come down over to about here, and they would be overlapping right there. They have to be, those two pieces have to be longer than the third side, than the longest side. So that's where this rule comes from. In general, if they told you you have side lengths that are lengths of 2, 3, and 4, and if they asked you if they're a triangle, you would want to add the two smaller ones and make sure that they would overlap, make sure that they're bigger than that longest side. So this one would be a triangle. So this is the rule that they're using to figure out which ones would make a triangle or not. So there's a longer process. I'm just going to use this way right here that we talked about. If our sides are 15 and 28, we're just going to try that with each one. 2, 15, and 28. So 2 plus 15 is not bigger than 28. Doesn't work. Okay, so let's do 12, 15, and 28. 12 plus 15 is 27. That's not bigger than 28. That would be like this one here. So would that one. They're not long enough to meet. Okay, this one, notice now we're bigger than 28, so your two small pieces are actually right here. Okay, and 15 plus 28 is 43. 43 is bigger than 31, so that's going to be the one that works. And you can tell right here 43 is not bigger than 44 or 52, so those also wouldn't work. This is a theorem you may not have heard in your math classes because of the way classes have been changed. All right, I hope you enjoyed Activate Week. Do great on the ACT, juniors.